day students. So how's your holidays? Hope you all have a good rest and we happy to meet again. Okay, the school is still on MCO holidays and just wait for the announcement when they reopens and when you are going to join the school. So till then we still have to go on the YouTube platform, and I also hope to do online classroom. I have some technical problems, so once it's ready, maybe I'll let you all know to join the Google online class. Okay, online class. Maybe later, sometime later. So till then, I still like to conduct on this YouTube platform on this lesson. And today we are going to see another concept about heat also. Okay, just to recapture, in the last class we studied about specific capacity, where the formula is itself defining the specific capacity as amount of heat required to increase 1 degree Celsius of substance of 1 kilogram of unit mass. So that's the definition of specific capacity. And then amount of heat required is equal to mc theta. And this is the concept we learned in the last class, and we did a number of questions and also an experiment to relate between the amount of heat and temperature. I think I discussed that in our PDP 5. If you look at that on the whiteboard, I wrote as PDP 4, but it's actually PDP 5. So now we are going to PDP 6, part 6, and today we are going to learn the concept of specific latent heat. It is an important concept also. Okay, to talk about, to understand the concept of latent heat, what we need to know is, okay, you will be, when you take, let's say for example, you take an ice cube, right? You start to heat up the ice cube, you put a thermometer there in the ice cube, right? You measure the temperature. Of course, ice cube is 0 degrees Celsius. So you start to heat up. Okay, you start to heat up. So when you're heating it up, you find that the ice start to melt. While the ice is melting, if you put the thermometer, you find that the temperature will give you still 0 degrees Celsius. You also still the temperature will read 0 degrees Celsius. You also still read 0 degrees Celsius. Earlier when we learned about specific capacity, we learned that when you heat up, the temperature goes up. But here, when you heat up, the temperature is not going up. The temperature is remain constant, but there is a change of phase. That means from solid to becoming liquid. Alright? And then after that you continue heat up, of course the temperature will go up until boiling point. So once it is the boiling point, okay, it's 100 degrees Celsius, and once start boiling, you continue heating it up, you will find that the temperature still remain the same, but you can see the water start vaporizing, the quantity of water start to reduce. Okay, the mass of water become less and lesser because the water is changing phase. So here you can see there's a change of phase. There's no change in the temperature. You are heating it up. Here also there's a change of phase. Here solid to liquid. Here liquid to gas or vapor. Also change in phase, and there's no change in the temperature. Okay, so this amount of heat that you are using it to change phase is known as latent heat. In Bahasa they call it pendam, haba pendam. That means something is kept. Okay, so if you look here, there are two types of latent heat. So for here we call it latent heat of fusion. That means the amount of heat required by the ice to change phase without changing temperature. So that's we call it as melting. And of course, when you reverse the process, let's say you take this ice water or water, you put it in the refrigerator, it will turn into ice cube. So here the heat is absorbed. Whether the heat is absorbed or released, here is the heat is released. Here is absorbed. To change solid to liquid, heat is absorbed. From liquid to solid, heat is released. Okay? In both the process, same amount of heat is involved. So this heat is the one we call it as latent heat. Similarly, here from liquid becoming gas, heat is absorbed. Similarly, if you reverse the process, this is boiling. If you reverse, we call it condensation. Okay. So here heat is released, the same amount of heat involved. But this amount of heat to change that 1 kilogram of ice, for example, to become liquid, the amount is not the same as for the 1 kilogram of water to become vapor. Both are latent heat, but the values are different. They need a different amount of heat to change phase. So if you look, you put it in summary. So the latent heat, so from solid to liquid, we call it fusion. Alright, so in the fusion, it's either melting or freezing, reverse process. Latent heat is absorbed. Whereas in vaporization, it's either boiling or condensation. So here, freezing, condensation. I think not freezing. This is boiling. Freezing. So in freezing, freezing and condensation, heat is released. Okay, reverse process, heat is released. Solid, liquid, liquid gas, heat is absorbed. Melting and boiling, latent heat is absorbed. Alright, so these are the things. Okay, so to put it in fact, okay, in summary, what is latent heat? Heat absorbed or released at constant temperature. Is it 0, 0 or 100, 100? At constant temperature during change of phase. Change of phase here means solid becoming liquid or liquid becoming gas, or vice versa. Gas becoming liquid, and here solid, liquid becoming solid. Okay, this is what known as latent heat. Latent heat, we call it specific latent heat, where the symbol we use here is L. For specific heat capacity, we use C. Later you will see the formula. It's a very simple formula. Once you know the formula and you understand this concept, I think you can solve problems and you can answer questions related to latent heat. Okay, if you look carefully here, look, this is a melting process. There is a time when you're heating it up, ice is melting, there is no change in the temperature. Alright? Whereas here, after all the ice has melted, then the temperature start to go up and then start boiling. During boiling process, there is no change in the temperature also. So this is latent heat of vaporization, latent heat of fusion. If we reverse, first latent heat of, we call it freezing, and latent heat of condensation, but still the amount is the same. Right? So we call it specific latent heat for both the cases. Okay. So what we are going to see now is the formula part. Okay. Suppose I take 1 kilogram of ice. Okay, I take 1 kilogram of ice. I heat it up until all the 1 kilogram of ice become ice water. Alright, 1 kilogram of ice becoming ice water. Temperature is the same. Okay, 0 degrees Celsius. So the latent heat here we define as amount of heat required to change 1 unit mass or 1 kilogram of ice to become from solid to liquid without change of temperature. So this is the definition, right, which we have explained that. This is my formula. So if you look at the unit, amount of heat is joule, mass is kilogram. So latent heat, the unit is joule per kilogram, meaning amount of heat required to change 1 unit of mass of a substance to change its phase without changing temperature. Okay? Okay, let us now look at a specific example. Alright? So So suppose, let's say latent heat of water, latent heat of water, I think it's 2.26. The value is latent heat of ice. Let us give give a specific value. Alright, fusion, latent heat of fusion for latent heat of fusion I put LF for water is 336,000 joule per kilogram. So what does it mean? That means you need to supply 336,000 joule of heat energy to melt 1 kilogram of ice from ice to become ice water without change of temperature. That's the meaning of latent heat. So you can see it. So similarly, if you, let's say just now we talk about vaporization, the water vaporizing for 100 degrees Celsius, boiling point, at boiling point, okay, vaporizes. So how much heat you have to supply for the water, 1 kilogram of water to vaporize, change its phase from liquid to become gas. So we call it latent heat of vaporization. For here, change of phase for vaporization is a bit higher the value, and it's 2.26 times 10 to the power 6. Yeah, 10 to the power 6 joule per kilogram. So this is latent heat of vaporization. This is fusion. This is latent heat of vaporization. Okay, alright. One important point, so we got to know. They like to ask is what is happening to the kinetic energy of the molecules. Okay, so when you heat it up, of course the molecule receives energy and they start vibrating. Okay, so it start vibrating, it is start to break the bonding, molecular bonding. Okay, from solid, okay, from solid it become now liquid. Okay, so the bonding is broken. So the amount of heat energy that you are supplying is actually to break the bond. That's why the temperature is not going up. That means the kinetic energy of the molecule is at the average is not increased. Whereas if you talk about specific heat, as the temperature goes up, that means the molecules are absorbing heat and the kinetic energy is changing. So the heat energy given is to change its kinetic energy. That means the molecule moving faster and faster. Alright, until it reaches the boiling point, it breaks the bond again. Then the heat they are supplying now is to break the molecular bond to become vapor. Alright, so then we call it vaporization. Okay, that's why in both the cases, the average kinetic energy of ice and average kinetic energy of the vapor is constant. Average kinetic energy. Yeah? But during the heating process, when the temperature start going up, here this part, temperature is from 0 is 100. So here the temperature is start going up. During this process, the kinetic energy increases. That means when you talk about specific heat capacity, actually the heat given to increase the kinetic energy. Yeah? That's why the temperature is going up. Whereas here the average kinetic energy, although the molecules are moving, but at average they are the same. Alright? So they are just given to break the bond. So definition you have to know. So in SPM they like to ask what is mean by specific heat latent of fusion for water, for ice is this. What is mean by this? So you have to say 336,000 joule of heat energy required to melt 1 kilogram of ice without change in temperature. Right? So that's how we explain it. They like to ask what is the meaning of this latent heat, or what is the meaning of latent heat of vapor. So you have to explain the amount of heat required. The amount of heat required to change 1 kilogram of water to become steam without change of temperature is this way. Alright? So this one, so the formula is very simple. So if we rewrite the formula, we get Q equal to ml. The amount of heat required, Q equal to ml. Okay? So we rewrite Q equal to ml. Alright? So the latent heat, L equal to Q over M. So it's rather a simple formula to solve, but just you need the understanding what is the meaning and how to use it. And usually SI unit for this is in kilogram. This is of course joule per kilogram. This is joule. So you can see kilogram multiplied per kilogram is usually left with joule. Right? So this is how the formula is used to solve problem. So that's a short concept that we are going to learn today. Okay. So most of the time, as we learned earlier, when we heat up substances, okay, usually we heat up, we use fire or gas, but for calculation purpose, usually we heat up using heater. Alright, electrical heater. So if the electrical heater, power of the electrical heater is P, and the time you take to melt, to heat it up for the melting process is T. So the amount of heat you are supplying from the heater is Q equal to PT. So if you are using electrical heater with power P and you heat it up for a time of T, then the heat energy given out by the heater is PT. Right? So PT, so therefore we can write Q equal to ml, so PT is equal to ml. Okay. So this is another form of formula when you are using electrical heater. But generally if you just use heat Q, then you just substitute the value with the joules. Okay. But other than that, if you are using electrical with the power P, power usually they give in like 1 kilowatt or 500 watt, then you just put it in watt. Time must be in seconds. Here the unit must be in watt, this must be in seconds. Okay, so both you multiply, of course the unit you get is joule again. And joule, the same Q, the unit for unit Q is joule, you are given. Right, so that's what you have to know. And maybe I give you a question here. The specific heat of latent heat, just listen. The specific heat of latent or fusion of ice is 336,000 joule per kilogram. What is the quantity of heat required to melt 2.5 kilogram of ice at 0 degrees Celsius? So very simple. 2.5 kilogram of ice you want to melt. Okay, 2.5 kilogram of ice you want to melt. That means M is 2.5 kg. We are melting it at 0 degrees Celsius. How much heat you require? Given specific capacity of ice is 336,000 joule per kilogram. So it's very simple. Q equal to ml. So therefore, M is 2.5, it must be in kg. L is 336,000. You just multiply. So you will get the answer. Give the answer to so we get 840,000. 840,000 joule of heat energy is required to melt. Suppose this ice water of 1 kilogram, you put it back in the refrigerator. You have to, the water will release this amount of ice and this amount of heat in order to turn back into ice cube. So it's the same. Here heat is absorbed to melt, the same amount of heat will be released when it changes space from liquid to solid. So both is known as latent heat of fusion. Okay. So this is what a simple concept that we are going to learn today. We have learned today with a simple example. So what I will do, I will give you some questions on this for you to get yourself familiar with this concept. Alright, then we will discuss the answers for the question in the next class. So there are a lot of other aspects involved in this about the interpretation of heating curve and cooling curve. When you're heating it up just now, we call it a heating curve. The curve flows like that. So if you cool it down, of course the curve will go like that. Alright, so all this we will discuss, and the application in daily life about latent heat. All these concepts, maybe once the school starts, I might go through again some of the abstract ideas that we can talk about the application during the class. So for today, we just understand about the concept of this, and then the application of the formula and understanding. So remember the definition of latent heat. Okay, just now I wrote here, amount of heat required to change 1 unit of mass of the substance, change the pace of 1 unit of mass of the substance without change in temperature. So no change in temperature, change pace, amount of heat required. These are the 3 important keywords. change of phase, no change in temperature, amount of heat required to change the phase. Alright, so that's what you have to know for today. So I'll give you some questions and then later followed by the answers. Then I'll discuss if there is any doubt on the questions. So remember, if you are using electrical heater, you must use PT equal to ML. No more Q. Q is replaced with PT. So I think that's all. So till we meet in another class with the questions. I'll post the questions. After this I'll post some questions. Then you try the questions and then I'll give you the answers. Then in the next class I'll discuss some of the answers for the questions and then we'll further discuss about some of the concepts. Alright. So for your reference, if you are using the printed notes, it is page 124 to 127. If you are using textbook, I am referring from page 137 to 144. So there they have discussed how to determine specific heat capacity and all that. Okay. So till we meet in another class, thank you very much. Have a good day. So be consistent with your work, as I've been telling you.